All right, today we're diving into strategic cloud optimization. But look, this isn't just some techie tune-up. We're going to talk about it as something that's absolutely essential for any modern business, a constant balancing act between raw performance, how much you're spending, and yeah, even sustainability. Okay, let's get into it.
So let me just ask you this straight up. Is your cloud secretly burning cash and slowing you down? Because it's an incredibly common problem. So many companies are over-provisioned, paying for stuff they don't even use, and under-optimized, leaving a ton of efficiency and money just sitting on the table. That's the core problem we're going to break down right now. And the stakes here? They're huge. We're not talking about tiny little tweaks that save you a few bucks. No. When this is done right by experts, this kind of strategic optimization can boost your performance while cutting your operating costs by up to 40%. I mean, that's a massive number that goes straight to the bottom line and affects your ability to compete. And sometimes the biggest wins are actually the simplest. Think about all your non-production stuff, your dev, your testing, your staging environments. Just by setting up an automated schedule to shut them down at night and on weekends when nobody's using them, you can slash the costs for those specific resources by up to 75%. It's the perfect example of a quick win with a huge impact.
And this really gets to a crucial point. Modern cloud optimization, it's not just about making things go faster anymore. It's this really sophisticated balancing act between four key things. You've got to deliver amazing performance, you've got to manage costs like a hawk, you've got to make sure you can scale up when you need to, and more, you've got to do it all in a sustainable way.
So here's our roadmap for this explainer. We'll kick things off with why you really need a holistic approach today. Then we'll get into the nuts and bolts of tuning your infrastructure and architecting for performance. After that, we'll look at how to automate intelligence and cost. And finally, we'll peek into the future of optimization.
All right, section 1, why this all matters right now. Honestly, if you take away one thing, it's this. You can't optimize in a vacuum. If you try to do it in little pockets here and there, it's just going to fail. Real, lasting optimization demands a holistic framework, an approach that looks at every single layer of your cloud stack, from the metal all the way up to your financial planning. So experts have broken this down into 8 strategic domains, which we can group into these 3 core areas you see here. But why is this big picture view so important? Well, because it's all connected. Think about it. If your infrastructure team saves money by picking slower storage, but that tanks your app's performance, did you really win? No way. You just moved the problem somewhere else. This framework makes everyone look at the whole picture, the foundational infrastructure, the software running on it, and the governance that holds it all together. So let's jump into section 2 and start right at the bottom of that stack, tuning the infrastructure. This is the foundation, right? The concrete stuff, your virtual servers, your storage, your network, that everything else you do is built on top of. The absolute cornerstone of tuning your infrastructure is this concept called right-sizing. And listen, this isn't a one-and-done thing. It's a continuous, ongoing process of making sure your compute resources, your CPU and memory, perfectly match what your app actually needs. Get it wrong, and you fall into one of 2 very expensive traps. Over-provisioning, where you're just burning money on idle machines, or under-provisioning, which means slow performance and unhappy users. So how do you automate this? Well, that's where autoscaling comes in. And the big cloud providers handle it a bit differently. On the one hand, you've got AWS, which is super mature and gives you incredibly fine-grained control, which is awesome for really complex setups. Then you've got GCP, which is often loved for its simplicity and has this killer feature, built-in vertical pod autoscaler support for Kubernetes. If you're running containers, this can be a total game changer, slashing the manual work needed to keep things sized just right. Okay, moving from compute over to storage, another basic tactic is tiering. The big idea here is simple. Not all data is created equal. You wouldn't keep a 7-year-old archive that you might look at once a year on the same expensive, super fast drive that runs your main database. So the cloud providers give you a whole spectrum of options, from hot storage for data you need in milliseconds, all the way down to deep archive, where it might take hours to get your file back. Matching your data to the right tier is a huge cost-saving move that a lot of people just forget about. Now, if you want to cut down latency and take pressure off your servers, you have to think in layers. This is the caching hierarchy. It starts right at the edge, with the user's own web browser saving things like images and logos. The next layer out is the CDN, or Content Delivery Network, which puts copies of your content in data centers all over the globe, so it's physically closer to your users. And finally, you have origin caching, which sits right in front of your database to handle the same repetitive questions over and over again without bothering it. But, and this is a really big but, we come to this unavoidable trade-off.
Every single performance layer you add, like those caching systems, also adds another layer of complexity to your architecture. So yeah, you made things faster, but now you have more moving parts to watch, to secure, and to manage. It's a strategic trade. You give up some simplicity to get better performance, and that means you absolutely have to invest in better tools to manage that new complexity.
And that is the perfect segue into Section 3, Architecting for Performance. So now we're moving up the stack from the raw hardware to how you actually design and build your apps. This is all about weaving speed and efficiency right into the DNA of your software from the very beginning. One of the biggest architectural decisions you can make today is choosing between microservices and serverless. Microservices are great for those big, complex, always-on applications where you need total control. The catch? You're paying for those resources 24/7, even when they're just sitting there. Serverless, on the other hand, breaks work down into these tiny event-driven functions. You only pay for the milliseconds a function is actually running, which is amazing for spiky, unpredictable traffic. The trade-off there is you usually have a bit less control and you're tied more closely to your cloud provider. Now let's talk about a bottleneck a lot of people don't even know they have. Their networking protocols. Sticking with old tech is like putting a speed limiter on your car. Modern protocols like HTTP/3 give you huge advantages. The biggest is getting rid of something called head-of-line blocking. Think of it like a single checkout lane at the store. If one person has a problem, everyone behind them is stuck. That's the old way. HTTP/3 is like opening multiple checkout lanes at once. One little delay doesn't stop the whole show. It's a massive real-world difference. For any app with a lot of data, a single giant database will eventually become your biggest problem. The solution is a technique called sharding. The best analogy is splitting a massive single phone book into 26 smaller books, one for each letter of the alphabet. It's way, way faster to find what you're looking for, right? Sharding does the exact same thing with your data, splitting it into smaller, faster, independent pieces. This not only makes queries faster, but also makes your system more resilient. And this brings us to a huge shift in thinking, especially with modern AI and machine learning. For decades, the answer to every performance problem was just throw more CPUs at it. But for these advanced apps today, the real bottleneck isn't raw compute power anymore. It's data access latency, how long it takes to get massive amounts of data from storage to the processors. This means your whole optimization strategy has to change, focusing more on low-latency data platforms than just adding more compute cores. This focus on data and cost leads us perfectly into Section 4, automating intelligence and cost. This is where you see this amazing merger of tech operations and financial planning, a movement called the FinOps revolution, and it's being supercharged by AI and automation. And right at the heart of this revolution is AI Ops, AI for IT operations. And look, it's not just a buzzword. Think of it as the smart brain for your entire cloud environment. AI Ops platforms are constantly analyzing data streams to spot problems before they happen, figure out the real root cause of an issue, and even predict future demand so you can scale up ahead of time efficiently. And the results? Well, they're huge. When companies really get AI Ops working for them, they're not just making things more reliable, they're seeing their total cloud bills drop by as much as 30%. That's intelligent automation turning directly into serious financial savings. And this chart shows one of the simplest, most powerful ways to automate cost savings. On the left, you see the cost of running a non-production environment 24/7. On the right, you see the cost when you just automate turning it off after hours. The savings, between 60 and 75%, are immediate and dramatic. It's a crystal clear picture of why automation is so key to controlling costs. Okay, let's apply this same thinking to how you actually buy your cloud resources. Because choosing a payment model isn't just about paying a bill, it's a core strategic decision. You are constantly playing this game, balancing the risk of an interruption against the reward of saving a lot of money. This risk-reward matrix lays it all out. On-demand instances, that's your baseline. You get capacity whenever you want it, but you pay full price. Reserved instances are like signing a lease. You commit for a year or 3, and in return, you get a huge discount and guaranteed capacity. And then there's spot instances. The savings are unbelievable, up to 90% off. The catch? The cloud provider can take that server back with just a 2-minute warning. The risk is high, but man, the reward is huge. So this leads to the one question that every single cloud architect and finance manager has to answer. What is the right mix for your specific apps? And there's no single right answer. It completely depends on what each application does and how critical it is.
The smartest solution is almost always a blended strategy. You use reserved instances to cover your steady, predictable, mission-critical stuff, the core that always has to be on. You use the incredible savings of spot instances for tasks that can handle being interrupted, like big data jobs or training your ML models. And you keep on-demand in your back pocket for those surprise traffic spikes or for short-term dev work. It's a portfolio approach that lets you get the best cost without sacrificing performance where it counts. All right, let's head into our final section and look into the crystal ball a bit at the future of optimization. The big trends are all pointing to systems that are not just more autonomous, but also way more aware of their impact on the environment. One of the coolest new techniques is something called carbon-aware scheduling. This is where your system is smart enough to know how clean the power grid is in different data centers in real time. So for a flexible job, say a big report that just needs to be done by tomorrow morning, the system can automatically move that job to a time or place where there's a ton of renewable energy. This is a double win. You lower your carbon footprint, and since green energy is often cheaper, you can lower your bill too. So to wrap this all up, let's hit the big takeaways from today. First, remember that for today's apps, the bottleneck is data flow, not just CPU. Second, automation, especially AI ops, is the critical bridge connecting your performance goals to your budget. Third, your appetite for risk has to be what drives your cost strategy. That's the whole spot versus reserve decision. And finally, never forget that making things faster almost always makes them more complex, and you have to be ready to manage that complexity. And that leaves us with a couple of final big questions for you to think about. As these cloud systems get smarter and more autonomous, how is your role going to change? It's definitely going to shift away from turning knobs and dials, and more towards setting the strategy and the rules for these automated systems. And maybe even more important, how are you going to measure success in a world where application speed, the cost, and your carbon footprint are all seen as equally critical? That is the challenge and the huge opportunity that's waiting for all of us. Thanks for joining.